Hi everyone. Hope you all can hear me well and also see my screen. And thanks for joining in. Hope you are doing great and most importantly, staying safe. So staying safe is the most important thing these days. I'm Prabhat Sirivardhana and I authored the book Microservices Security in Action with Nuwan Dias. Uh, and the book is released now. I think last week it got released from Manning side, and it will be available on Amazon first week of August. So you can pre-order from Amazon even now. The book is focusing on microservice security, and it covers different aspects of microservices security in 5 parts: overview, and then edge security. There we talk about how you can secure your north-south traffic in your microservice deployment using an API gateway. And we also have end-to-end scenario working with single page application, and how you can secure, how you can access microservices from that single page application. Then under service to service communications, that's part 3. So there we talk about how you can secure the service to service communications with certificates. So that's the most popular approach. Then we talk about how you can secure service to service communications in JWT. And then we also talk about how you can secure gRPC services and also reactive microservices with Kafka. Then secure deployment. So we have 3 chapters under part 4. There we talk about how you can secure a Docker container which hosts your microservice, and then how you can securely deploy your microservice in Kubernetes, and then how you can secure your microservices, the east-west traffic using Istio Service Mesh. Finally, in part 5, secure development. So there we cover like the best practices in building secure code and test them using static code analysis and dynamic testing, and how you can automate those stuff. Okay, you can ask any questions using the Zoom chat, using the Twitch chat panel. Okay, yes. So in this session today, I'm mostly focused on chapter 12, how you can secure your microservice deployment using Istio Service Mesh. Let me quickly go through the book. So this is an ebook. We have 1 chapter on like how to secure your microservice with Istio Service Mesh, and then if you are new to Istio, we have an appendix, the appendix K. It covers the service mesh fundamentals. Okay, so let me adjust the screen so I can see your chat panel. Let me just here. Okay. Yes. So so this appendix gives you a high-level understanding of Istio Service Mesh. Let me quickly go through the architecture, and then we'll go through a set of samples. So this is in fact the architecture that you see in Istio prior to 1.5. So in fact, when I got started writing the book, we started with Istio 1.4, and then Istio released 1.5, and then we upgraded 1.5, all the samples. 1.5 actually had a major architectural change. And then towards the end of the book, like April this year, then Istio released 1.6, and we also upgraded all the samples to support Istio 1.6. So the architecture you see here is, in fact, what you see prior to 1.5. So here you can see the Istio control plane and data plane. In control plane, you see 3 main components. In fact, there are 4 main components. The 4th one is not shown here. The pilot, citadel, and mixer. So pilot takes care of defining routing rules and configurations and pushing them to the data plane or to the Envoy service proxy running in the data plane. Then Citadel takes care of managing the workload identities, creating certificates and provisioning certificates to the Envoy service proxies, and it makes sure the certificates are properly, timely rotated. Then a mixer, so this is a major change Istio 1.5 brought into the Istio architecture. So now you won't see a mixer in the Istio control plane, at least by default. But before 1.5, the Istio's extensibility revolved around mixer. So you can write authorization plugins, login plugins, and monitoring plugins, and extend the Istio capabilities using mixer. In addition to that, there's another component, Galley. So Galley sits between the pilot and the underneath platform. So that is Kubernetes. So pilot doesn't need not to know necessarily how to talk to the Kubernetes APIs. It simply gets updated with respect to Kubernetes configuration by talking to Galley. So Galley knows how to talk to the underneath platform and feed the pilot with the relevant data. Then you have the data plane. In data plane, along with your service container, you will also see a proxy called Envoy. So Envoy proxy will intercept all the traffic coming into your microservice, into your pod, and also going out of your pod. In addition to that, Istio also has an Istio ingress gateway and Istio egress gateway. So all the traffic coming into your Istio deployment will go through the Istio ingress gateway. So once again, Istio ingress gateway has Envoy proxy, and all the traffic going out of your Istio deployment will go through the egress gateway. Okay, so that's a high level architecture of the Istio before 1.5. So with 1.5 onwards, you won't see like independent executables of pilot, Citadel, and mixer. So you will have single deployment unit called Istio D. So Istio D will include all pilot, Citadel, and the Galley. It won't include mixer. And also, since 1.5, the extensibility of the Istio Service Mesh is now revolving around the proxy, Envoy proxy. So you can write Envoy plugins or filters using with the support of the WebAssembly. Okay, so with that, let's move into the samples. So all the security samples you can find in chapter 12. And also, if you go to this Git repo, you can find all the samples. The samples I'm going to use in this session, you can find them under chapter 2. Okay. And also, so there are some commands that you need to skip if you are using Istio 1.6. So those are documented here in the README file under chapter 12. Okay, so let's go back to the chapter. So first, we are going to create this deployment in Kubernetes. Okay, so this is a deployment we want to create. Right? So here you have the order processing microservice, then inventory microservice, then the security token service. Right? So and you also have an application. So this can be a web application, single page application, and any kind of an application. For this particular demo, I'm using a simple curl client for that. The objective is you need to secure this order processing service and inventory service both with mutual TLS and JWT. So we should be able to enforce authorization policies based on the attributes coming in the JWT, both at the order processing service end and also at the inventory service end. And secret token service is the one which will issue a JSON web token to access the service from the curl client. So this is the architecture we are going to build. First, before getting into Istio specific configurations, I'll show you how to build this deployment using the Kubernetes artifacts, right? So you need to create a deployment for order processing service, inventory service, and then the security token service, all three microservices. So to do that, you can find here, this is the deployment of the STS microservice. So you can see the STS deployment. And here, this is the container I'm using to run the security token service. And then this deployment is exposed to the STS service. Right? So here I'm exposing this STS service as a node port service. You don't need to expose this as a node port service when we integrate this with Istio. Right now, I deploy this as a node port service. So before we go into Istio, I can just test it from my curl command line client. Okay, and also you can see the configurations are defined under a config map, and also the secrets are defined under Kubernetes secrets. That's the definition of STL, the STS, and then the inventory microservice. Its deployment is defined here, just like in the previous case. Here we don't need to expose the inventory microservice. Like from my curl client, I don't need to talk to the inventory microservice. It's something that we don't want to expose outside the Kubernetes cluster. So here I haven't specified a service type. So when you don't specify a service type, by default Kubernetes uses cluster IP. So you cannot access a Kubernetes service which is of the cluster IP type from outside the Kubernetes cluster. And then the order processing microservice. So this is a deployment of the order processing microservice. Here, once again, I'm using node port type because I need to get a token from the security token service from my curl command client. And then I need to use that token and access the order processing microservice from outside the Kubernetes cluster. So there also I'm using node port type. And yes, so this service is exposed through port 80. And if you go to STS, so that is exposed through port 80. So these are not secured. These are just simply using HTTP. And then inventory microservice is also exposed through port 80. Right? So now let's apply these configuration files. So now let me do kubectl apply. Okay. Now all got applied, and I'll be using this shortcut for this in the future. Okay. So that is for kubectl apply -f. Now I got my Kubernetes deployment created. Now let's see the services. Now you can see there are three services that got created: STS service, order service, and the inventory service. You can see the STS service is of node port type, order service also of node port type, but inventory service is cluster IP type. Right? So now to in my Kubernetes cluster, there's a master node and there are two other worker nodes. So to access any of these services, I need to pick the IP address of a given node, right? So that's the disadvantage of using node port types rather than going for a load balancer type. You always need to know about the IP address of the node that you are going to access service, right? So here, let me export my IP address here. Yes, this is my node IP. In fact, if you do nodes, you'll be able to find all the nodes running in my Kubernetes cluster. So I exported the node IP. And then to access STS service, I need to use the node IP along with the node port. So in this particular case, this is the node port, right? For the order service, this is a node port for the STS service. So let's export that to again. Now the STS node port is this one, and I need to export another one, the node port of the order service. This is the node port of the order processing microservice. Now I can use this curl command. So this curl command is using the environment variables we already set up in our environment. And here you can see I am doing curl request. So this is using both password grant type. So you should not be using this in production. You may be using authorization code grant type with your single page application or with your web application. Here just for the to the demo purposes, I'm using the password grant type. So when I type this one, this should hit the order processing microservice, and they should return the JWT. Okay. So now you got a JWT from the STS, and now you can, now let's try out to invoke the order processing microservice using another curl command, just to see it's working. Now still the order processing microservice is not secured. You can access it over just HTTP and without any JWT. Right? Okay, so let's run this one. Now it's also working. So here I'm doing a get. Now let's also try doing a post. So when we do a post, the request directly goes to the inventory microservice, and then request directly goes to the order processing microservice, HTTP post. Then the order processing microservice will do a post to the inventory microservice. Okay. You will just see a 201 here. Yeah, you just get a 201, right? So the resource got created. And now we can visualize what happened in this deployment using this dashboard called Kiali. So I'm running Kiali in my environment. If you go to this console, Kiali console, you can see the traffic flows. So let me enable security, and I need to see everything in default and Istio system namespace, workload graph. Yeah. Now this should show me the traffic. It'll take a little bit of time to refresh. Okay, let me send more requests. So this basically shows our deployment, but you will see some color on these arrows when, okay, now you can see, right? So here, this is our curl client. From curl client, you send a request to the order service and then go to the orders deployment. And yes, now you can see the complete thing. And the order service will invoke the inventory microservice. So it still takes some time to get updated. And this is the request I used to talk to STS and got the JWT. Let me send more requests, and let's make it 5 minutes. Okay. So another request. Another one, and also let's do a curl to the STS. Let's refresh. You should see a green arrow in these lines too. Yeah, now you can see this is a request we send from our curl client to STS. You all HTTP, right? So no TLS here. This is also HTTP. This is also HTTP. Ideally, this should be MTLS because so I'm using the auto injection proxy in my Istio deployment. So that means I have set a label to my default namespace. So whenever we deploy a microservice, or when you create a deployment, in Kubernetes default namespace, Istio will attach the Istio proxy or Envoy proxy. So all the requests coming to these services will go through that. So here there's a proxy. So it'll and here also there's a proxy. So all the traffic coming out of the order processing microservice will go through the Istio proxy and hit the Istio proxy in the inventory service. So this should be MTLS enabled, but it takes some time to find that. Maybe we can revisit it. Okay, so now request. Okay, now you can see that line, but this should be MTLS. Yeah, now you can see the complete thing. So this line is HTTP, and here it's MTLS. This is a call happening inside the Istio deploy, right? So the request comes to the Istio proxy here. Istio proxy will deploy it to the order processing microservice. When order processing microservice talks to the inventory microservice, it will also go through the Istio service proxy of the orders deployment. Then it will make sure the communication with the inventory service happens over MTLS, right? This is done by Istio out of the box. So that's a feature Istio 1.5 introduced. Auto MTLS is now enabled in your Istio deployment. You don't need to do anything. It's enabled out of the box. But here there's no Istio involved, right? So the request is generated from outside client, and it directly hits the STS and order processing microservice, even though they have the proxy. From the client side, there's no one to enable MTLS. So we just invoke the request from our curl client. So that is why you won't see any MTLS here. Okay. Now after that, what we need to do is we go to the book. So all the steps are here. Here you can see we enable Istio auto injection. So you need to set Istio injection enabled to your default namespace. The label using set that value under the default namespace. So this is what we saw now, right? So in our case, there is no load balancer. We invoke the Istio, the STS microservice from our curl client, got a token, and then we talk to the order processing microservice. So this proxy is there already, and the proxy intercept the request, but still this is HTTP. Then this talk to the inventory microservice, right? So if we are using Istio 1.5, then this is HTTPS MTLS. But before 1.5, this is just HTTP, right? Now let's see. Okay, so this we did how to enable TLS at the Istio Ingress Gateway, right? So when you have Istio in your system, you need to make sure all the requests coming from outside the Kubernetes cluster first go through the Istio Ingress Gateway, right? Then to do that, first we need to enable MTLS, or first enable TLS, provision keys, and enable TLS at the Istio Ingress Gateway. Then Istio Ingress Gateway will use MTLS between the Istio Ingress Gateway and the corresponding service proxies. Okay. Now to enable TLS at the Istio Ingress Gateway, first we need to generate a key pair. So let's see how to generate the key pair. If you look at this document, you should be able to see. You can run this OpenSSL client. OpenSSL client, if you have installed OpenSSL in your local machine, or else you can use this Docker image. So I'm using the Docker image. That's more convenient. Okay, so I'm running my OpenSSL client, and then I'll type this command. So it will generate a private key and a public key for my Istio Ingress Gateway. Sorry, it's the wrong command I did. I need to run this command. It's an OpenSSL command. So this will generate the keys. And now I need to run the previous command I ran, this one. So this will create a Kubernetes secret with the keys I just generated, right? This will create a Kubernetes secret with the keys I generated. The server key and the server cert are the ones that we generated from the OpenSSL command. Run it from the gateway keys directory. So here you can see the keys. Okay, so now you can see we created a secret called ecom credentials, and let me list out the secrets. Okay, this is the credential we created, this Kubernetes secret we created, and we created that in the Istio system namespace because we are going to use it in with our Istio Ingress gateway, which is running in the Istio system namespace itself. Okay. So done. So now the next thing we need to do is we need to create a gateway, right? So before that, let me go through the definition of the gateway. So Istio introduced two new CRDs, gateway resource and the virtual service resource, right? So gateway resource CRD and the virtual CRD together help the Istio Ingress gateway to route any request it gets from outside the Kubernetes cluster to the corresponding workload, right? So those two, they have to work together. Okay. So let's have a look at the gateway resource first. Okay. So this is the gateway resource. So this gateway resource operates at the layer 4, right? So it will look at the port and the protocol and will try to find out the corresponding virtual service, right? And a given gateway resource has to be associated with an ingress gateway, right? So you know the ingress gateway. Now the gateway resource defines set of configurations that can be used by the ingress gateway to route traffic to a workload, right? So now to attach this gateway resource or this particular configuration to the ingress gateway, I need to use this one. Yeah. To the ingress gateway, I need to set this label here, right? Istio Ingress Gateway. If you look at the Istio Ingress Gateway deployment, which is in Istio system namespace, get deployments, Istio system and Istio Ingress Gateway, and let's say show labels. Okay. So here you can see there's a label called Istio Ingress Gateway, right? So now when we define a gateway having this selector, Istio Ingress Gateway, this gateway resource will get attached to the Istio Ingress Gateway, which is running under the Istio system namespace. Okay. And then here it says any traffic comes to any HTTP traffic, HTTPS traffic comes to port 443 for any host, pick this configuration, right? Also, any traffic that comes to port 80 HTTP traffic, also pick this configuration, but redirect to the HTTPS, right? But this itself doesn't say anything about the service. This only says pick this resource if there's any traffic comes to port 443 HTTPS, right? Then this is not just enough for the Istio Ingress Gateway to route traffic to a given workload. Now, once Istio finds its gateway resource, pick this particular gateway resource, it will also try to find out what are the virtual services associated with this particular gateway. Now, if you go to our virtual service definition, right, this is the virtual service definition of the order processing microservice. Here you can see this defines a host element, right? This host element should mesh with the host element we define in the gateway resource. Now, what is that gateway resource? This is the full qualified name of the gateway resource, right? And also, even though the gateway, the value of the gateway element matches with the whatever the gateway picked by Istio, that doesn't enough. You also need to mesh the elements we define under the values we have defined under the host element, right? So here we have asterisk under the host element in our gateway resource. So this virtual service will match, and also this is attached to that particular gateway. And in fact, you can attach a given virtual service for multiple gateways, and one gateway can route traffic to multiple virtual services. So now, looking at this configuration, Istio will pick, okay, this is the gateway, this is a corresponding virtual service, and still we don't know how to route traffic to the Kubernetes pod. Here it says this is a routing rule. You need to route any traffic come to this virtual service to the port 80 of the order service Kubernetes service. So this is the name of the Kubernetes service. So this is, if you go to the order service definition, which we showed you before, order service. Here you can see, if you look at the Kubernetes service definition, so it is listening on port 80, right? So now, whatever the traffic comes that particular virtual service will be routed to the corresponding port using this particular service definition, right? So that's how Istio will route traffic comes to the Istio Ingress gateway to the corresponding port. If you have any questions, please feel free to ask in the Twitch chat. Okay, so now one more thing. If you look at the gateway resource, here, this is how we set up the credentials, right? So you remember we created a secret called ecom credentials with the public and private key we generated. So we need to set the name of that credential here, right? So this is how you set up Ingress gateway if we are using SDS or the secret discovery service supporting Istio. So Istio introduces SDS support since Istio 1.1, but it was not supported out of the box. You had to use a profile called SDS. But since Istio 1.5, this is available under the default profile. You don't need to go for like SDS profile. It's available under SDS Istio default profile, but it is still available only for the service proxies out of the box. It's not enabled for the Istio Ingress gateway. So if you are using 1.5, you need to do some stuff, additional stuff defined in this book. You need to enable it for the Istio Ingress gateway, right? So this is how you do that, right? You need to, yeah, it's not with SDS, yeah, with SDS. With 1.5, you need to update the Istio manifest to enable SDS for the Ingress gateway. But if you are using 1.6, you don't need to do that. Okay. So since we are using 1.6, we can skip these two steps. So now let's create the gateway resource. Okay, so this create the gateway resource, and now we'll also create the virtual resources. Virtual services. Okay, so now I think we have the entire setup up and running. Now we can test it. Let's say get virtual services. Yeah. So these are the two virtual services we created, and you can see both of them are bound to the Ecom gateway, and you can see Ecom gateway is running in the Istio system namespace, not under the default namespace. Okay. So now we can try out the same thing we did before, but now we need to route the request to our order processing microservice through the Istio Ingress Gateway. So both the requests going to STS and the order processing microservice now will go through the Istio Ingress Gateway. Let's go to the diagram and see. So if you look at this diagram, maybe it's a little down. Yeah, if you look at this diagram, now all the requests coming to our proxy will go through the Istio Ingress Gateway, right? To the STS and also to the order processing microservice. This will be secured with HTTPS. It was not secured with HTTPS before. And if you are using Istio 1.5, this communication will once again be out of the box enabled with MTLS support, right? But if you are using prior to 1.5, if you don't do any changes, then this would be simply just HTTP. Right? Now let's try out the sample. Okay. So first I need to find out the node port of the Istio Ingress Gateway. To do that, let's discover services in the Istio system namespace. Istio system namespace. So now you will see the Ingress Gateway, Istio Ingress Gateway, right? And this is defined as a load balancer, but since I don't have an external load balancer, I need to access this through a node port IP. Basically, I need to find the IP address of the node which runs this Istio Ingress Gateway. It runs on all the nodes. Now, since I'm using HTTPS 443, I need to use this as my port, right? So let's export this as export Ingress HTTPS port. This one. Right? So that's the only thing I need to do. I already set up the node IP, right? So now let's try out this. Here you can see I'm sending a curl request to the STS, but here this request goes through the Ingress Gateway, not through the not directly hitting the service through the Kubernetes Ingress, right? Once again, I need to do some update to the STS deployment and the order processing deployment. You may remember earlier when we deployed those two services as Kubernetes services, we used the node port IP address, node port service type, because we wanted to access those two services directly from outside the Kubernetes cluster. Now we don't need to do that because we are sending all the traffic through the Istio Ingress Gateway. If you do get services, right, you can see order service and STSS both are node IP types. Now let's update these deployments to work with cluster IP. So you won't be able to access this service directly. If you want to access, you must go through the Istio Ingress Gateway. Right? So you can find the updated configuration here. Yeah, this is the updated configuration. This is cluster IP, and then you should have the same for the STS. Yes. Okay, that's also cluster IP. Let's update this. Now, if you get services, you can see, okay, still it's not port. Okay, that's a reason, right? The reason is if it is a node port IP service, when you just update it, it won't update because here we are removing the service type. So you need to delete the service and updated, right? So let me delete it. Delete service STS. Delete service. What is service? Okay. Now let's run the same command we did before. That, right? So now if you do get services, you can see all the services are of class type service type. Right? So that means I cannot directly access these services without going through the Istio Ingress gateway. Now let's see how to access these services through the Istio Ingress gateway. Here I'm using a curl command, same curl command I used before to get a token from the STS, but I'm using the accessing this through the Ingress Istio Ingress gateway, right? So here I have environment variable defined for the Ingress HTTP host port and the node IP, and here I am using a domain name called sts.ecom.com, and I am resolving it to this particular IP and the port. Right? So let's run this one. Okay, so now this return me back a JWT, and let's run the other command to try to access the order processing microservice directly. Still, we don't do any JWT validation. We just enable TLS. That TLS at the Ingress gateway. We haven't enforced any authorization policies at services, so we don't need to pass the JWT here. Right? So without a JWT, we should be able to access this. We should see a 201. Yeah. So now we could access the inventory microservice securely. Now let's go back to the KRE dashboard and see what happens. It usually takes some time to get updates. Okay, now you can see Istio Ingress gateway here, right? So all the traffic to the order processing microservice and STS, they go through the Istio Ingress gateway. Now it should show all the traffic and should see all the connections are secured with MTLS now. Yeah, so let me send more requests. Okay, now you can see this channel. Here you can see MTLS is enabled between the Ingress gateway and the order processing microservice, and also the MTLS is enabled between the order processing microservice and the inventory microservice, and this should also have MTLS. It may take some time. Yeah, now you can see here also from the Istio Ingress gateway to the STS, you have enabled MTLS. So all the connections in our service mesh is now protected with MTLS. We did nothing. Only thing we did was like we just enable TLS, the Istio Ingress gateway. Out of the box, Istio 1.5 onwards, MTLS is enabled between all the microservices. And once again, one thing you need to understand is, even though MTLS is enabled from 1.5 onwards, it doesn't necessarily enforce MTLS at each service. What does that mean? That means even though this client decides to use MTLS to access this microservice, if you have another client who doesn't want to use TLS, you can simply access the order service without TLS, right? So that means you haven't enforced MTLS at this particular microservice, right? So that means either you can access service with MTLS or without MTLS, but out of the box in Istio environment, you have MTLS enabled. Any request going, any request coming from Istio service proxy that will have MTLS between the two services, right? So let's see how this works, right? So let's try to break this flow. To break this flow, first I need to tell, let's say, to the Ingress gateway not to use TLS to talk to the order processing microservice. By default, if I say nothing, it will start using MTLS, right? So this is how you say not to use MTLS at the Istio Ingress gateway. You need to define a destination rule, right? So you know the gateway and virtual services both together will be able to find out how to route traffic to a particular to a particular destination, right? The destination rules define once the workload is found or the service is found, how to talk to that, like whether to use TLS or MTLS or whether to enable a circuit breaker or not. So those stuff can be defined using a destination rule. Right? So now let's see how to define a destination rule. You go to the destination rule definition. So if you look at here, so this destination rule, we apply it to the Istio system namespace. So that means this destination will be applicable to any request generated from the Istio system namespace. And it will be applicable only if those requests are going to orders microservice in the default namespace. So this is a full qualified name of the order processing microservice. And what should you do? It's a traffic policy, disable MTLS, right? So let's apply this policy. Okay, so now we apply this policy and let's try to invoke the order processing microservice again. Let's do a few requests. Now let's refresh this one. Let's pick 1 minute. Okay. Now you can see there's no MTLS enabled between the Istio Ingress gateway and the order processing microservice. It still passes. So that means even though by default MTLS is enabled, the Istio doesn't enforce it, right? So that's why now we can talk from Istio Ingress gateway to order processing microservice without MTLS, right? Here you have MTLS enabled between the order processing microservice and the inventory microservice because we didn't instruct order processing microservice not to use TLS when it talks to the inventory service microservice. Now let's see how to enforce MTLS at the order processing microservice, right? So then Istio Ingress gateway should not be able to talk to the order processing microservice with no MTLS, right? To do that, from Istio 1.5 onwards, you need to define a peer authentication policy, right? So I have sample peer authentication policy here. You go to peer authentication policy. Yeah, this one, right? Here it says any request coming to a deployment which matches its orders label, right? So this orders label will match with the order processing microservice. You must use MTLS, right? Strict. So when you say strict, you must use MTLS. If you say permissive, that means either you can use MTLS or not, right? So let's try to apply this policy. So this policy will be applicable to any service, any deployment carrying the orders label in the default namespace. Okay. So now what's our expectation? This should fail, right? So when you try to invoke the order processing microservice, it should fail because here we say you must use MTLS, but we have instructed Istio Ingress gateway not to use MTLS, then we should find an error, right? So let's try to do a curl. Yeah, now you can see it fails. You get a 503, right? Okay, it takes some time to update. You can see 503. Okay, so that is because we instructed this guy not to use MTLS and we instructed this guy to enforce MTLS. Now let's delete the destination rule we applied to the Istio system namespace. Let's remove that. Delete destination rule. Yes. So we deleted that. Now this request should succeed again. Yeah. Now it works as expected. Okay. So if you refresh it, you will see once again, yeah, everything is protected with MTLS. Okay, so next we'll see, let's go to the book. This we already did. So now let's see how to enable JWT based authentication and do a service level authorization with the attributes coming in the JWT. Right? To do that, you need to define a request authentication policy. So both this peer authentication CRD and the request authentication CRD is still introduced from 1.5 onwards. Earlier, you had to use something called policy, which will include both certificate-based validation and JWT validation together in a single CRD. And now, basically, Istio deprecated that from Istio 1.5 and removed support for the policy CRD since Istio 1.6, right? So now, to do request authentication, right? So you need to define a request authentication CRD. You go here. Request authentication policy. This says the kind is request authentication, and this is applicable to the orders microservice. You need to bring a JWT, right, to access the service, and the issuer of the JWT must be sts.ecom.com, right? And the audience element in the JWT should match this value, and you specify the URL to fetch the public key of the secret token service, which signs the JWT, so Istio can verify the signature. Right? So we'll go through what this means later, the forward original token attribute later. Right? So now one thing in Istio is, even though if you enforce a request authentication, if there's a JWT in the request, and if it is not valid, Istio will block the flow. But if there's no JWT in the flow, you will let the request hit the service, right? Now to prevent that, along with the request authentication, you also need to define an authorization policy, right? So request authentication will validate like what's in the JWT. If there's no JWT, it will let go. But in either case, the authorization policy will check whether you have the request principles in the system, right? So that means if there's no request principle, you cannot talk to the microservice, right? So that means to populate the system with the request principle, you need to authenticate first, right? So you need to apply both the policies together. So that means even if you don't bring a JWT, you won't be able to access the service. Authorization policy will block that, right? So we have defined a request authentication and authorization policy for the orders microservice and also for inventory microservice, right? Let's try to apply these two policies. In fact, the 4 policies. For request authentication policy. Request authentication policy. Okay, so now we applied that. Now if I try to invoke the order processing microservice now, it should fail without a JWT. Right? So now I don't have a JWT. Let me store token. Right? So there's no JWT in the system. So here JWT is loaded from this particular environment variable. So I set it to empty. Now this should fail, right? Yeah, this, okay. Still takes some time to update. Okay, now you can see access denied, RBAC access denied. We are trying to access the microservice without a JWT. Now let's try to invoke the service with a JWT. So first I need to talk to the STS and get a token. So this is a JWT I get. And if you go to jwt.io, you'll be able to decode this. Here you can see the issue is sts.ecom.com. So that will match with the policy we have defined in our request authentication CRD. And then audience is also *.ecom.com, which will also match with our configuration. Now I'll export this as export token. Now if I try to invoke the Authentication microservice, it should pass now. You can see it's a 201, right? If you want to do more fine-grained access control, you can expand the authorization policy, right? So this is how you do that. You go to request authorization policy here. There's another authorization policy. Here it says, basically the authorization policy CRD was introduced from Istio 1.4, and in 1.4 you could only use allow here, right? Only the allow action. Then Istio 1.5 supported both allow and deny. So if you are using 1.4, you only can do allow, but with 1.5 onwards you can do both allow and deny. Right. So here it says you are allowed to access this service, right? If you are doing HTTP GET or a POST, and also the username in the JWT is Peter, right? If you look at our JWT, it's Peter, right? Should allow username. This is exact attribute ID, right? Here you find exact attribute ID. Then the scope is foo, and also the role is role user, right? So basically you can define any claims that you can get from the particular JWT and define the rules here. Okay, so let's try to apply this policy. So this policy's name is request authorized policy. Okay, so now we applied another policy. Now there are two policies which could be applicable to our Authentication microservice. So there's no straightforward way of finding out what are the policies applicable for a given microservice, because that's based on labels. So I created this particular command that will be helpful to find this out. Right, so if you run this command, it will show you all the authorization policies applicable to this app orders label. Right, now you can see two policies, right? So when there are two policies applicable for a given service, if there's one deny policy, then the request will be denied. And if all the policies are say allow, at least one policy matches, then you will let the request access the service, right? So here in our case, both the policies say allow, then we should be able to access a resource. So let's try to access the Authentication microservice again. Yeah, we can successfully access it. Okay. So now let's do a deny here. Let's say deny, right? Now, so we have one policy allow, one policy deny. So you will be denied only if the request matches with this criteria, right? So in our case, it matches with our criteria. So the request will be denied, access will be denied, right? So let's apply the authorization policy again. Okay, done. Now let's do the curl request. Now this should fail. Take some time. Yeah, now you can see access denied. It takes a little bit time to update. Yeah, now you can see you get a 403, the access denied, because we have a deny rule which will override the allow rule. So let's go back to this from here. One thing to notice is, if you look at this diagram, right? So this is what we have, right? So everything is MTLS enable, and also we are passing a JWT now. No, this is the one. Yeah, here it's not shown in the diagram, but here we are also passing a JWT. You may remember that I talked about this when you're talking about the authorization policy. request. Yeah, request authentication policy. So here we say forward original token, right? So this policy is applicable to the orders processing microservice here, right? So you get the JWT. Now Istio, the proxy will validate the JWT and dispatch a request. Now once again here also we say you need to bring this particular JWT. Now by default Istio won't forward the same JWT it got from here to here. You cannot define it even in a policy. Right? So you need to do it manually. So what I have done is, so I have written a handler here, which will get the JWT from this proxy, right? It will come with along the request and send the same JWT. Basically, you inject it from your service code to the request going out to the inventory microservice, right? But if you don't say forward original token to true, then this proxy won't send the JWT it got to the order processing microservice, right? It will basically stop it there. Right? If you have a PO authentication policy, sorry, request authentication policy, and it won't forward the JWT to the to your microservice unless you say forward original token. So that's why I have said true. Okay. So now I think we have the end-to-end system secured. So you talk to from curl to the ingress gateway protected with HTTPS. And Istio Ingress Gateway securely talks to the proxy using MTLS, and also you pass a JWT, right? Here, this is STS. Here you pass a JWT, and this proxy will validate the JWT. And then when the order processing microservice wants to talk to the inventory microservice, there also we have enabled MTLS, and you will be passing JWT, and both the proxies will carry out authorization checks based on the JWT. Yeah, I think that's what I wanted to cover in this session. Any questions you will discuss? So, okay, then thank you very much, and hope you will get the book and enjoy reading that. And if you have any questions, we also have a Slack channel for our book. If you go through the book intro section, we have specified, like we have mentioned the invitation to Slack channel. Please join that, and if you have any questions, we can discuss there as well. And thank you very much for joining, and stay safe. Thank you very much.